Hi everybody, in this video we're going to talk about solving equations where we have variables on both sides of my equation. These are very different than the ones we've done before. They start off different, but you'll notice that by the end of this, you'll be using the same skills that you've already practiced in stations 1, 2, and 3. This video will be a little bit longer just because I really want to make sure we're able to explain each step, so bear with me. You'll notice on your note sheet, this example is already done out for you. We didn't want you to have to worry about writing down the steps as you went. We just want you to watch and listen. So stay with me here, and then I'll pause and give you a chance to work on your own. The reason that we talk about these being called equations with variables on both sides is because, as you notice, I have an x on the left side of my equation, and I also have an x on the right side of my equation. So if I were to draw my train tracks, just like I always do, you'll notice that I have two different sets of x's. I have 3 x's on the left, and I have 2 x's on the right. The first thing that I need to do is think about my inverse operations to subtract the smaller variable to the other side of the equation. I can't have x's on both sides of my equation. There's no way that I could get it by itself in that case. So I see 3 x's on the left and 2 x's on the right. The first thing I'm going to do is subtract 2 x's from both sides of my equation. Notice that I'm lining up both terms with the x already there. 2x minus 2x, that disappears. 3 x's take away 2 x's would just leave me with 1x. So I had 3 x's, I'm taking away 2 of them. Now I'm just going to copy down the rest of my equation that I haven't worked with yet. At this point, this equation should look very simple and easy to solve for you because you've already practiced this part many times. I see that x minus 16. The opposite would be to add 16 to both sides. I'm left with just an x on the left side, and I'm left with 22 plus 16, which would give me 38 on the right-hand side. So the beginning of this equation looked very different, but by the end, it looks just like all the other ones we've solved up till now. Now this part is a little bit different. When we check our equation, we need to check both sides of the equation because both sides have an x in it. So I'm going to come up back to the beginning, and I'm going to do one side at a time. So the first side of my equation says 3 times x minus 16. That's my left side of the equation. I'm going to type that into my calculator. 3 times 38 minus 16. And that's going to give me an answer of 98. I'm going to do the same exact process now with the other side of my equation. So this time, 2 times x plus 22 should give me the same answer. So I'm going to type this whole side into my calculator. 2 times 38 plus 22. And luckily, I get 98 again. Because I have the same number, the same answer on both sides, that means that I can say confidently that I have done this problem correctly and that x is equal to 38. So you'll notice that the beginning of this problem was different. We had to use those inverse operations to move our x terms to the right or left side, and then continue using our inverse property after that to move our negative 16 and to find our final answer, okay? So what I would like you to do is I would like you to pause the video, and I would like you to start this problem. So to get you ready, there are our train tracks. In this problem, I see a 3x on the left and a 6x on the right. I always subtract the smaller x value. That just helps me not have to deal with as many negative numbers. So to get started, I'm going to subtract 3x from both sides. I'd like you to pause the video there and try it out on your own, and then join me back here in a few minutes. All right, hopefully if you're back, you've found a value for x. Let's figure it out together and double check. So the first step, like we said, was to use those inverse operations to subtract the smaller variable. In this case, 3x was smaller than 6x. I've canceled this out on this side to be left with just 12. 6 x's take away 3 x's, still leaves me with 3 x's. And I slide down that minus 3. From here, I know I need to use my inverse operations again. I see that minus 3. The opposite would be to add 3. I'm left with 15 equals 3x. And my last step to get x by itself would be to divide by that coefficient. So 15 divided by 3, I would be left with x equaling the number 5. And remember, if you don't like the fact that it's written backwards like this, you can always rewrite it as x equals 5 for yourself. All right, now the most important part, the check. I'm going to come all the way back to the beginning, and I'm going to check the left side. So 3 times 5 plus 12. 15 plus 12 would leave me an answer of 27. You can type that all into your calculator all in one piece, including parentheses. Now I'm going to come up and check the right side. 6 times x minus 3. 6 times 5 is 30. 30 minus 3 still gives me 27. So because I've gotten the same answer for both sides of my equation, I know confidently that x equals 5. So you're going to use your inverse operations to move your smaller x value first, then continue solving just like you normally would. If you need help, please ask your teacher or rewatch these examples. Come back, rewatch them again if you need help. They'll be here the whole time. Start working on your station practice page.